From the previous parts of history of rockets, we talked a lot of things about early rocketry and early rocket science. If you didn't watch them, you can watch them here and I will also put the links in description. Anyway, from this video, third and the last part of history of rockets, we're gonna talk about the modern rocketry. From early 20th century rocket pioneers to today's rockets. In the modern era, spaceflight historians often acknowledge three fathers of rocketry who helped push the first rockets into space. Admittedly, the term singles out a person who may have been in charge of a large team and also comes from an era when people were less sensitive about the use of gendered language. Still, these individuals have a large footprint on the development of rocketry as we understand it today. Only one of the three survived long enough to see rockets being used for space exploration. In 1898, a Russian schoolteacher, Konstantin Tsiolkovsky, proposed the idea of space exploration by rocket. In a report he published in 1903, Tsiolkovsky suggested the use of liquid propellants for rockets in order to achieve greater range. Tsiolkovsky stated that the speed and range of a rocket were limited only by the exhaust velocity of escaping gases. For his ideas, careful research, and great vision, Tsiolkovsky has been called the father of modern astronautics. Early in the 20th century, an American, Robert H. Goddard, conducted practical experiments in rocketry. He had become interested in a way of achieving higher altitudes than were possible for lighter-than-air balloons. He published a pamphlet in 1919 entitled A Method of Reaching Extreme Altitudes. It was a mathematical analysis of what is today called the meteorological sounding rocket. Goddard's earliest experiments were with solid propellant rockets. In 1915, he began to try various types of solid fuels and to measure the exhaust velocities of the burning gases. While working on solid propellant rockets, Goddard became convinced that a rocket could be propelled better by liquid fuel. No one had ever built a successful liquid propellant rocket before. It was a much more difficult task than building solid propellant rockets. Fuel and oxygen tanks, turbines, and combustion chambers would be needed. In spite of the difficulties, Goddard achieved the first successful flight with a liquid propellant rocket on March 16, 1926. Fueled by liquid oxygen and gasoline, the rocket flew for only 2.5 seconds, climbed 12.5 meters, and landed 56 meters away in a cabbage patch. By today's standards, the flight was unimpressive, but like the first powered airplane flight by the Wright brothers in 1903, Goddard's gasoline rocket was the forerunner of a whole new era in rocket flight. Goddard's experiments in liquid propellant rockets continued for many years. His rockets became bigger and flew higher. He developed a gyroscope system for flight control and a payload compartment for scientific instruments. Parachute recovery systems were employed to return rockets and instruments safely. Goddard, for his achievements, has been called the father of modern rocketry. The third great space pioneer, Hermann Oberth, born on June 25, 1894 in Transylvania, and died on December 28, 1989 in Nuremberg, Germany, published a book in 1923 about rocket travel into outer space. His writings were important. Because of them, many small rocket societies sprang up around the world. In Germany, the formation of one such society, the Verein-für-Raumschifffahrt, led to the development of the V-2 rocket, which was used against London during World War II. In 1937, German engineers and scientists, including Oberth, assembled in Peenemünde on the shores of the Baltic Sea. There the most advanced rocket of its time would be built and flown under the directorship of Wernher von Braun. The V-2 rocket was small by comparison to today's rockets. It achieved its great thrust by burning a mixture of liquid oxygen and alcohol at a rate of about 1 ton every 7 seconds. Once launched, the V-2 was a formidable weapon that could devastate whole city blocks. Fortunately for London and the Allied forces, the V-2 came too late in the war to change its outcome. Nevertheless, by war's end, German rocket scientists and engineers had already laid plans for advanced missiles capable of spanning the Atlantic Ocean and landing in the United States. These missiles would have had winged upper stages, but very small payload capacities. With the fall of Germany, many unused V-2 rockets and components were captured by the Allies. Many German rocket scientists came to the United States. Others went to the Soviet Union. The German scientists, including Wernher von Braun, were amazed at the progress Goddard had made. Both the United States and the Soviet Union realized the potential of rocketry as a military weapon and began a variety of experimental programs. At first, the United States began a program with high-altitude atmospheric sounding rockets, one of Goddard's early ideas. Later, a variety of medium and long-range intercontinental ballistic missiles were developed. These became the starting point of the US space program. Missiles such as the Redstone, Atlas, and Titan would eventually launch astronauts into space. On October 4, 1957, the world was stunned by the news of an Earth-orbiting artificial satellite launched by the Soviet Union. Called Sputnik 1, the satellite was the first successful entry in a race for space between the two superpower nations. Less than a month later, the Soviets followed with the launch of a satellite carrying a dog named Laika on board. Laika survived in space for 7 days before being put to sleep before the oxygen supply ran out. A few months after the first Sputnik, the United States followed the Soviet Union with a satellite of its own. Explorer 1 was launched by the US Army on January 31, 1958. In October of that year, the United States formally organized its space program by creating the National Aeronautics and Space Administration, the NASA. NASA became a civilian agency with the goal of peaceful exploration of space for the benefit of all humankind. It took several more years before either country felt confident enough to use rockets to send people into space. Both countries started with animals. Russian cosmonaut Yuri Gagarin was the first human in space, leaving Earth on April 12, 1961, aboard a Vostok K rocket for a multi-orbit flight. About 3 weeks later, Alan Shepard made the first American suborbital flight on a Redstone rocket. A few missions later in NASA's Mercury program, the agency switched to Atlas rockets to achieve orbit, and in 1962 John Glenn became the first American to orbit Earth. When aiming for the moon, NASA used the Saturn V rocket, which, at 363 feet tall, included 3 stages, the last one designed to be powerful enough to break away from Earth's gravity. The rocket successfully launched 6 moon landing missions between 1969 and 1972. The Soviet Union developed a moon rocket called N-1, but its program was permanently suspended after multiple delays and problems, including a deadly explosion. NASA's Space Shuttle program used solid rockets for the first time to boost humans into space, which is notable because unlike liquid rockets, they cannot be turned off. The shuttle itself had 3 liquid-fueled engines, with 2 solid rocket boosters strapped on the sides. In 1986, a solid rocket booster's O-ring failed and caused a catastrophic explosion, killing 7 astronauts aboard the Space Shuttle Challenger. The solid rocket boosters were redesigned after the incident. Rockets have since been used to send spacecraft farther into our solar system. Past the Moon, Venus and Mars in the early 1960s, which later expanded into the exploration of dozens of moons and planets. Rockets have carried spacecraft throughout the solar system, so that astronomers now have imagery of every planet, many moons, comets, asteroids and smaller objects. And, because of powerful and advanced rockets, the Voyager 1 spacecraft was able to leave our solar system and reach interstellar space. Several companies in many countries now manufacture uncrewed and crewed rockets, the United States, India, Europe, China and Russia, to name a few. And routinely send military and civilian payloads into space. Each of these countries has their own complex history of rocketry across many booster types, which often come with numerous variants for heavier loads or smaller loads, or different celestial destinations. Meanwhile, crewed spaceflight continues to proliferate. The Russians have used variants of their Soyuz rocket for decades, bringing humans into space across several different versions. NASA now has 2 streams of rocket providers, one set commercial and one set agency directed. For International Space Station missions, the agency is using the SpaceX Crew Dragon system aboard the SpaceX Falcon 9 rocket. Modified from a booster variant used for satellites, the hope is to use in the near future. NASA also plans to use a Northrop Grumman Starliner spacecraft, which would launch aboard either Northrop Grumman's Antares rocket or United Launch Alliance's Atlas V. Further afield, NASA is also developing a space launch system to launch astronauts to the Moon and potentially Mars, following at least one SLS test launch this decade. Rocket technology continues to change rapidly in private industry, with milestones often occurring in a period of just months. We'll just point to a few trends. SpaceX and Blue Origin have pioneered the use of self-landing rockets. Numerous companies are launching clutches of satellites on a single rocket as satellite technology continues to improve and miniaturize. Rockets are getting lighter and more adaptable through 3D printing, more efficient fuels and continued improvements in machine learning. As of early 2022, space tourists and commercial astronauts now have choices of several rocket or spaceplane systems developed by Blue Origin, Virgin Galactic and SpaceX. Space tourism may be the trend to watch for the 2020s and 2030s, although for now it is largely confined to the super rich. The most high-profile future rocket system in development is Starship and its Super Heavy rocket, a SpaceX project that is expected to bring NASA astronauts to the moon in the short term and settlers to Mars in the much longer term. The system changes quite rapidly between iterations, and as of early 2022, it has yet to achieve a space flight. But founder Elon Musk has been committed to the project for many years and regularly shares updates on Twitter in between launches.